In this video, we'll look at radical equations, equations that are quadratic in form, and factorable equations. So let's start with radical equations, and we're going to look at the difference between odd root equations and even root equations. So in an odd root equation, meaning the third root, the fifth root, the seventh root, etc., you isolate the radical to solve it. You raise both sides of the equation to the appropriate power to remove the radical. And then there's no restrictions with odd root radicals. You don't have to check the solution. I'm going to show you how that is different from even root equations once we do a couple. So let's look at this one. We have cube root of 2x minus 4 minus 2 equals 0. The first thing you want to do is isolate the radical. So I need to add a 2 to both sides. That gives me the cube root of 2x minus 4 equals 2. And now we are going to raise both sides of the equation to the appropriate power. So I need to cube both sides of that equation. So I cube this side, I cube this side. The cube root and the cubing undoes, and we have 2x minus 4. 2 cubed is 8. I add a 4 to both sides. 2x equals 12. We divide by 2, and you can see that x equals 6. And there's really no weird thing that happens during that type of solution when the root is an odd number. So let's do another one. Here I have the fifth root, so I need to isolate this radical. So I'm going to do that by subtracting a 2, and I get the fifth root of x plus 4 equals negative 2. We're now going to raise both sides to the fifth power. So x plus 4 equals, remember this means negative 2 times negative 2, negative 2, negative 2, negative 2, 5 times. So you end up with negative 32. We subtract a 4 from both sides, and we get x equals negative 36. Pretty simple, very straightforward. That is different than even root equations. There are some issues with even root equations. First off, it says requirements. We either have to be taking the root of something positive if the root is even, or whatever's underneath has to equal something positive. It can look either way. You're going to see examples in just a second. We're still going to isolate the radical. We're still going to raise both sides of the equation to the appropriate power to remove the radical, but in the case of even root equations, you must check your solution because extraneous answers can be introduced, answers that don't work. And you'll see an example of that. So here, it is an even root, it's a square root, and the radical is already isolated, so we're going to square both sides. That gives me 2x plus 6 equals 36. I subtract a 6 to isolate my variable. I get 2x equals 30. We divide by 2, and we get x equals 15. However, we can't count on that actually being the answer. So we're going to go up into our even root equation, and we're going to plug it in and check it in the original before we ever squared. So it would be the square root of 2, take out the x, put in the 15, plus 6 equals 6. Or the square root of 36 equals 6. And obviously it works, so that one worked just fine. Now don't assume just because that one did that all of them will. This one, the radical is isolated. So we're going to raise it to the fourth power on both sides. That gives me x plus 2 equals a negative raised to an even power is a positive, and negative 2 to the fourth power is positive 16. Subtract a 2, and I get x equals 14. Have to check. So the fourth root of x is 14 plus 2 equals negative 2. Is the fourth root of 16 equal to negative 2? Now, in this case, we mean the principal root. So is the principal fourth root of 16 negative 2? No, it's not. It's positive 2. So my answer has to be discarded, and the solution is the empty set or no solution. And I'm sorry to tell you, but that just happens sometimes when you raise an even root to its power, that you get extraneous solutions. All right, let's try another one. This is square roots. So the radical is already isolated, so we're going to square both sides. Notice what gets squared is the whole side, so the negative is included. So that gives me x plus 6 equals x squared, a negative x times a negative x. Now I see that I have a quadratic, so I'm going to get it equal to 0. I'm going to subtract the x squared, and then I'll show you what we're going to do to get it back to being positive. So negative x squared plus x plus 6 equals 0. And we talked before, if your squared term is negative, multiply everything by -1. That will change the sign. So x squared minus x minus 6 equals 0. It is a quadratic, so you have multiple ways to solve it, but I'm always going to check first to see if it's factorable. Are there factors of -6 that make -1? Yes, there are. So this is factorable. So x minus 3, x plus 2 equals 0, and we now use the 0 factor property. Either x minus 3 equals 0 or x plus 2 equals 0. I'm assuming you can solve those two, and you get either x equals 3 or x equals -2. But I still have to check them both in the original. So let's check 3. That would have been square root of 3 plus 6 equals the opposite of whatever we found for x is the principal root of 9, -3. No, it is not. So x equals 3 does not work. Let's check x equals -2. Square root of -2 plus 6 equals the negative of -2. Be careful with your signs. Is the square root of 4 equal to 2? Yes. So in this one of the solutions worked and one was extraneous and did not work. All right, let's look at this one. Again, it's an even root. It's a square root. So we're going to square both sides. And I think for space, I would like to get a blank sheet of paper. And we're going to do this one on a blank sheet. So let me get this copied on. We have square root of x minus 1 equals x minus 7. And let's do this one. It's right here. This is example 2D. So I'll do that on this paper so that we have more space. So we're going to square both sides. Now that doesn't mean x squared and then -7 squared. It means the whole thing squared. So x minus 1 equals, if you square this, that's x minus 7 times x minus 7, and you have to FOIL. You're going to get x squared minus 14x plus 49. I see that I have a quadratic, so I'm going to get everything onto one side equal to 0. I'm going to subtract an x and add a 1. Subtract an x and add a 1. I get 0 equals x squared minus 15x plus 50. As my quadratic, it is a short process trinomial if it is factorable. If not, I'll use the quadratic formula. I'm looking for factors of positive 50 that combine to make -15, -10, and -5. So it is factorable. So x minus 10 times x minus 5 equals 0. 0 factor property. Either x minus 10 equals 0 or x minus 5 equals 0. We solve those and we get x equals 10 or x equals 5. Again, we have to check before we squared in the original problem, which was square root of x minus 1. Let's check 10. Square root of 10 minus 1 is equal to 10 minus 7. Square root of 9 is 3. That is true. This one works. Now, that doesn't mean that this one doesn't. They could both work or not. You have to check them both. So let's check 5. Square root of 5 minus 1 equals 5 minus 7. Is the principal root of 4 equal to -2? It is not, so we discard that, and we have only one solution. X equals 10 is the only one that works. All right, I'm going to put this sheet aside and go back to the notes pages. And we are now going to look at solving equations that are quadratic in form, but we're going to be making a u-substitution. So when you look at an equation like this, I've got something squared plus a coefficient times that same something not squared minus a third number equals 0. So it's definitely quadratic in form. We are going to say let u equal, and it's always going to be this piece, the one that is same as this but not squared. So let u equal x plus 2. So that would give us u squared, because u is equal to x plus 2, so I'm substituting, plus 11u minus 12 equals 0. We're going to see if it's factorable. Since it would be a short process trinomial, I would need factors of negative 12 that combine to make positive 11. That's an easy one. Positive 12 and negative 1. So I have u plus 12 times u minus 1 equals 0. Zero factor property, u plus 12 equals 0 or u minus 1 equals 0. Solve those and I get u equals negative 12 or u equals positive 1. Now, here's the part that is hard about, not hard, but easy to forget. We are not finished. We made a u-substitution, but we were really looking for x. So we have to go back to our u-substitution and say u equals negative 12. So I'm going to substitute that negative 12 back in for the u. So negative 12 equals x plus 2. So this is called back substituting to find out what x is. I subtract a 2 and I get x equals negative 14. That is a solution, that x equals negative 14. So that I got that from that u. Or u could be 1. So I'm going to put a 1 in for the u. 1 equals x plus 2. Subtract the 2 and I get x equals negative 1. So my solutions are actually negative 14 and negative 1, not negative 12 and 1. I just used those to find my x. All right, on this next one, I'm going to do this equation two different ways. It kind of just depends on how you see it. It says find the real solutions of the equation by using the substitution method, which we just did, or treating it as a radical equation. So I'm going to start out, let's do the u-substitution method first. And if you look at that middle term, if I squared that, I would get this one. So we're going to say, let u equal square root of x. This is a little bit harder to see. That would give us u squared, because x squared would be, radical x squared would be x, plus 2u equals 3. Subtract the 3 to get it equal to 0, and I have u squared plus 2u minus 3 equals 0. I'm looking for factors of negative 3 that combine to make positive 2. That's positive 3 and negative 1. So u plus 3 times u minus 1 equals 0. U plus 3 equals 0 or u minus 1 equals 0. U is negative 3 or u is 1. I'm assuming you can solve those two baby equations. Now we have to go back and say, yeah, but u is this. So we're going to say, let's do negative 3. So negative 3 is equal to the square root of x. How do I solve that? I square both sides. And I get x equals 9. Now we're going to have to check that. We're going to check it because I had to square here. I didn't have to check the one up here because in my solution when I substituted back, I didn't do any squaring. Whenever I do any squaring, I've got to check it. So let's check that 9 and then we'll use the 1. So to check 9, I would say in my original equation is 9 plus 2 times the square root of 9 equal to 3. Well, you can see it's not going to be true. Is 9 plus 2 times 3 equal to 3? No. So that doesn't work. So now we have to check the 1. Check 1. Or we have to put it back in first. Don't check 1. Don't do what I just said. We have to actually put it back in. Back substitute. So if u is 1, I'm going to use this to back substitute. So 1 is equal to square root of x. Square both sides, and I get x equals 1. And now I want to check 1. And when I check 1, and by the way, it just happened that x was 1 and so was u is 1. That happens sometimes. That's okay. But you still had to do this. You still had to back substitute. So to check 1 is 1 plus 2 times the square root of 1 equal to 3. Is 1 plus 2 equal to 3? Yes, it is. So we only got one solution. That was kind of a hard way to do that problem. So let's treat it as a radical equation instead. And with a radical equation, we have to isolate what the radical. So let's write this. X plus 2 square roots of x equals 3. I need to isolate this, so I'm going to subtract an x. That gives me 2 square roots of x equals 3 minus x. Now I'm going to square both sides. Don't forget to square that 2. That gives me 4x equals, FOIL this out, 9 minus 6x plus x squared. I have a quadratic, so let's get everything equal to 0. 0 equals 9 minus 10x plus x squared. Let's write it in our more familiar order. X squared minus 10x plus 9 equals 0. Now, is that factorable? Are there factors of 9 that combine to make negative 10? Sure. Negative 9 and negative 1. So I get x minus 9, x minus 1 equals 0. So x minus 9 equals 0, or x minus 1 equals 0. I get x equals 9, or x equals 1. I would have to check them both since I did squaring to solve. However, we already did this here. When we back substituted, we first got x was 9 and it didn't work, so I don't need to do that again. All right, it's still not going to work. And then I got x equals 1 and it did work, so it still is going to work. You get to the answer a little bit more quickly using the radical method than the substitution method, but either way is perfectly fine. All right, we have one last problem. One last type. Higher order equations. Higher order than square root or cube root. So what you do is you bring everything to the left side, remove the GCF, and use the zero factor property. These are pretty easy. So we're going to get everything equal to 0. So what I'm going to do is I'm going to subtract the 4x squared from both sides. I get x to the 4th minus 4x squared equals 0. Now I'm going to factor out the GCF, which is x squared, and I'm left with x squared minus 4 equals 0. But I'm not finished because this is difference of two squares. So x squared, now I know this is going to be x plus 2, x minus 2 equals 0. Zero factor property says either x squared equals 0, or x plus 2 equals 0, or x minus 2 equals 0. Solving those, I get x equals 0. Here I'm going to get a negative 2, and here I'm going to get a positive 2. So I actually got 3 answers, but those are easier than I think than some of the ones we did earlier. Same thing here. Let's add the 27x squared to both sides. So plus 27x squared. That gives me x to the 5th plus 27x squared equals 0. And now we are going to factor out the GCF, which is x squared, and we're left with x cubed plus 27 equals 0. This one is tricky because you have to recognize that what is left in the parentheses is still factorable. That is sum of cubes. So let's bring down our GCF. Sum of cubes has a small parentheses and then a big parentheses. It's what got squared first. What got squared here is, or cubed, excuse me, is a 3. So first, second, first one squared, multiply them together, second one squared. Same, opposite, always positive. That's the rule of cubes. So what got squared or cubed here was an x. What got cubed here was a 3. So first, second, first one squared, multiply them together, second one squared. So now I have to say zero factor property, either x squared equals 0, or x plus 3 equals 0, or x squared minus 3x plus 9 equals 0. And in this case, this is going to give you a complex solution, an I solution. We only want real solutions, so we're going to ignore that. I would have had to use the quadratic formula. So here I can solve those two easily, and I get x equals 0 or x equals negative 3. Now I'm going to go over here on this other sheet, and I'm going to show you this one to show you what I'm talking about. It was x squared minus 3x plus 9 equals 0. It's not factorable, so I would have had to say a is equal to 1, b is equal to negative 3, c is equal to 9, and x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a, or x equals 3 plus or minus 9 minus 36 all over 2, x equals 3 plus or minus square root of negative 27 all over 2. And I'm not going to take it any further because now you can immediately see that you're going to get a complex solution, and we only want real solutions on this problem. So just saying that when you have a perfect cube, a sum of cubes, this piece is going to provide you with a complex solution. This one gives you a real solution, so does this one. All right, let's look at the last problem. We have x to the third minus x squared minus 4x plus 4 equals 0. It says, what is the clue telling you how to begin? And the clue is 1, 2, 3, 4 terms. So we are going to group. This negative here causes me to have to make a correction there. My GCF here is x squared, and I'm left with x minus 1. My GCF here is 4, and I'm left with x minus 1. So my factors are x minus 1 times x squared minus 4 equals 0, but this isn't finished factoring. So x minus 1, x plus 2, x minus 2 equals 0. And now I set each of them equal to 0 using that zero factor property. And when I solve by adding a 1 here, subtracting a 2 here, and adding a 2 here, I get x equals 1, negative 2, or positive 2. So I actually got 3 solutions there.